All right, hello students. Welcome back to CAD 140. Today we're going to do some more 3D modeling in using Autodesk Inventor software. I would first like to go over the objectives with you, which will be posted in Canvas a little bit later for my online students. However, my face-to-face students do have the objectives. So can I get a volunteer to read out loud what the first objective is, please? Okay, Potter, go ahead.
Students will create a flanged bolt hole circle using Autodesk Inventor software.
Okay, so we're going to create a flange today. And it's a special type of flange because we have a variety of holes. Can I get somebody to read the second objective, please?
Students will demonstrate how to create a variety of machine holes, through hole, counterboard hole, countersink hole, gate hole, and spot face hole, moving the hole feature in Autodesk Inventor software.
Okay, so that's tapped hole, not to be kind of nitpicky, but we have a through hole, and that is spelled correctly, is THRU. Through hole, a countered board hole, countersink hole, a tapped hole, which is a threaded hole, internal threaded hole, and a spot face hole. Spot face holes are primarily used for rough surfaces or castings. We have a rough surface and you want to seat the head of the bolt properly, and it won't seat properly because it's a rough surface, kind of irregular shaped surface. So you have to give it a machine surface to seat the head of the bolt or a screw. It could be a screw, either one. All right. So without further ado, I would like to go ahead and we've gone over the objectives. I also gave you a handout of what we're trying to create today. All right. Any questions before we get started? Okay. All right, here we go. Jackson, just find a seat and it's going to be recorded, okay? I'm going to go into, just 1 second here. Share my screen. All right, so what you will see is actually this is a flange that I created. I'm actually creating some OER material for a grant. That's why it has OER6 flange bolt hole circle multi-hole. Okay. This is the same picture that you have on the handout. And if you open this up here, this shows you the drawing. There's one dimension missing, and I'll tell you which one that is as we work along, okay? All right, so let me stop this share, and I'm going to go into Inventor. All right, so you will have access to that. I will post in the announcement about this module for my online students. Everyone is doing well on the online side and the face-to-face side. We're just a little bit behind on the face-to-face side because of login issues, and that's being resolved as we speak. All right, just like before, we're going to start a new file. All right, so we're going to go to New. Please select New. All right, now remember, if your screen looks like this, when you first select New, you have to expand here. Have to hit that arrow so that you can see the units, right? Because we're going to be making drawings in English, and we're going to be making drawings and models and using the metric system as well. If you look on your drawing today, we are using the English system of units today. So we're going to select English. All right, that's the first thing we do. The next thing we're going to do is we're going to select standard IPT. Does anybody remember what IPT stands for? What does the extension IPT stand for? Inventor part. Inventor part. And if you notice in parentheses here, it says inches. Okay, so we're going to select this icon right here. And then we're going to come down here to the lower right-hand corner and select create. And now your screen should look like this. Okay, your screen should look like this. And by the way, after we're done creating a strong, you will work in groups, looking up some YouTube videos as a group on some of these hole processes. Again, you're going to be machining these holes in this flange. And this will probably we'll probably make this towards the end of this semester. If we don't get to it, we'll make it I'm talking about the machine class. We'll make it in the following semester in MAC 162. All right. So the top left-hand corner, we have to create a sketch profile first. So start 2D sketch, and then select start 2D sketch again. As before, you'll see there's 3 intersecting planes here. Mr. Morris likes to, 99% of the time, I make all my sketches in the XY plane, but sometimes there is a need to use the YZ plane and the XZ plane. All you have to do is take your mouse and hover over the planes to see which ones they are. Now, this is the frontal plane, this is the right side plane, this is the top plane. So I'm going to select the XY plane. Okay. Now I said we have to create a sketch. If you look on the drawing I gave you, the flange is a big circle, right? It's really a circle. So up here on your menu, please hit the down arrow under circle and then select circle center point. Click on circle center point. Move your cursor to the origin. Remember, this is the y-axis. This is the x-axis. The intersection of the two is your origin. Remember your math class, you had to plot points. Well, this is where you're going to be using a lot. Now, I clicked on that intersection and I'm going to drag, just move my mouse and I'm dragging out a circle. Now, you don't have this dimension. I'm going to give it to you. It's 2.5 inches in diameter. So I'm going to type in 2.5, enter. Do a right click with your mouse, select OK. Mr. Morris, I can't see the geometry. I know. So what you have to do is you have to rotate the scroll wheel on your mouse to zoom in and out. Okay. So you can also hold the scroll wheel down and move your mouse around, and you can pan, just like other software applications that uses the scroll wheel, okay, for zooming in and out and so forth, and panning. That's a closed profile. I'm ready to give, this is a 2-dimensional sketch. I now need to give it some depth. So I'm going to select Finish Sketch. Again, I need to zoom out. All right, I'm going to take a breather just for a second. Is everyone with me? All right, cool. I see the thumbs up back there. All right, we have to give some depth to this circle in order to make the flange. Okay, it's really it's going to be a cylinder after we add some depth to it. So go to extrude. Right here's the icon for extrude. Now, does anybody remember the reason why I don't like to extrude? If you look down in the lower left-hand corner, you'll see the X and the Y and the Z axis. This is called the UCS icon. And notice that the positive Z is the default. How come Mr. Morris likes to change the direction, which I'm going to click right here, and I'm going to give some depth to it. Based on our drawing, it's 0.375 inches thick. Make sure you type that in correctly and select OK. By the way, if you ever mess up, you know, you have the undo button up here, the top left-hand corner, undo, or you can redo. Okay. Now, how come I like to extrude in the negative Z direction? Does anybody recall? Remember I said when you're setting up a CNC machine, you like the top of the workpiece to be Z0. And when you're cutting when you are cutting the material, you want to go in the negative Z direction, not positive Z, you're cutting air. Okay, you're cutting air with the tool. So to cut material, you're going to go in the negative Z direction. All right. Now, we have got to add our holes to this now, and you have not used this function yet. You've been using circles to create your holes, and that's fine, but now we have to be more exact in what we're looking for. So click on Start 2D Sketch, Start 2D Sketch, and click on this face right here. Okay, so Mr. Morris made a boo-boo. How do I fix that? Hit the escape. Okay, we'll do it again. Sorry. Start 2D Sketch, Start 2D Sketch, and click on that face. Now I know it's right because I've got my y-axis and my x-axis centered on the part, and my line of sight is normal to this plane. This is what your screen should look like. Now, can somebody look at the drawing and tell me what the bolt hole circle dimension is? What is the diameter of the bolt hole circle? It's the dashed line. It's the center line. What is the diameter? Talk louder. It's 1.875 is what it should be. Okay? We're going to place 4 holes on the bolt hole circle and then 1 in the center. All right. So what I need for you to do, we're going to draw a circle, but it's for construction purposes only. We're not going to keep it. So go to circle, select circle center point, move your cursor to the origin. See how it turns green? As soon as it turns green, click and drag out a circle here. Now, what is the dimension again? 1.875. Y'all know Mr. Morris can't hear atomic bomb go off, so you have to talk loud. Enter. Do a right click. Okay. All right, now, the reason I did this for is because I want to use the 12 o'clock position, the 3 o'clock, 6, and 9. But I'm going to do it one at a time. I'm going to add 1 hole at a time to this part. Right here on your menu bar, you will see point. See where it says point? Click on point. Move your cursor right here, and you will feel it snap. You will not turn green at this point, but it will move to the intersection of your at the 12 o'clock position. I said intersection, but I meant the y-axis in the circle. Okay, click. Do a right click. Select OK. What have I done? You have to have a Superman vision to see it, but if you if you move in, it's there. Okay. Mr. Morris can't see it, but you guys are young, you can see it. I'm going to finish the sketch now. This is important. Finish the sketch. Now we're going to create a hole. You've never done this before. So at the 12 o'clock position on your drawing, it says we want to put a 1/4-20 UNC-2B. What does that mean, Mr. Morris? The 1/4 means the diameter of the hole. 20 means the number of we're going to make a threaded hole, also known as a tapped hole. A 1/4-20 UNC. No, it's not the University of North Carolina, as some students have put in the past. It stands for Unified National Course. And then we have a classification of fit, which is -2. And B means it's an internal hole. If it was an A there, you would have external threads like the screw itself. But we're making a hole. All right, so watch this. Go to hole. All right, now it's going to lead us step by step what we need to do. This is a through hole here. I don't want a through hole. I want a tapped hole. So I'm going to select this one, the one that has threads in it. Select that one. Now, right here, we don't want a seat. You have a counter bore, you have a spot face, a countersink. I don't want a seat for this one. So select no seat, none. All right. Now, things are getting easier for us. If you come down here where it says threads, it's a 1/4. 0.25 is a 1/4, right? What's the what is the fractional equivalent for that decimal? 1/4, right? You got to get in that mindset when you're a machinist, be able to go from fractions to decimals. So it's 0.25, right? So you can arrow down, you can pick other decimals, but you want 0.25. And look here, sometimes the inventor thinks for us. It already has the thread designation here, 1/4 20 UNC, which is fine. And then we have the classification of fit, which is the 2B. Okay, excuse me just a second. All right, so far so good. Now, if you come down here, you want to terminate the hole. In this case, we want the hole to go all the way through the part. And I hear a little bit of talking back there. I hope y'all are working on this. We want the threads to go all the way full depth. And here we go. Now all the threads. See it? Look, if I uncheck that, look what happens. If I uncheck that, it's asking for a dimension. Okay, well, I want the threads to go all the way through the part. So I'm going to say full depth, the threads all the way through the part, select OK. Now, if you zoom in, you will see that you have threads in the hole. Questions? Congratulations, you created your first hole. All right. That's the threaded hole. Now we have to create our next hole. Go to Start 2D Sketch. Start 2D Sketch and click on this face. Again, if they were all the same hole, we'd be done already. But they're not. They're, 5 different holes here. So we have to go, excuse me, circle center point, click on the origin. It turns green, click, drag it out. What's this diameter again? 1.875. Enter. Do a right click. Okay. Apologize for my voice being so rough this morning. All right. We're going to put a point here. Select point and go to the 3 o'clock position, and you can feel it. You can actually feel it in the mouse. So select this point right here. Do a right click, select OK. You can't see it, but if you hover, you can see it. If you hover over that point, you can see it. Finish the sketch. Notice how each hole has its own sketch. Okay. Select hole. Now, how many of y'all have ever used a countersink hole? Have you ever seen a countersink hole, Dean Staub? Yes. What's it for? For a flathead screw, right? So that the top of the screw head is flush with the surface of the part. All right. We need to create that. If you look at the call out on the drawing, it says the diameter that goes all the way through is 0.27 to give clearance for a 1/4 inch screw. And that the major diameter, the larger diameter part, the conical part, if you will, has a diameter of 0.51 and an angle of 82 degrees. Here's how you create this. So we don't want threads now. We want it to be a simple hole. All right. We do want to have a seat this time. We do want a seat. So the seat is right here. This is a countersink. All right. Now, we have to fill out some of this information. We do want this countersink screw to go all the way through the part. What is the major diameter here? 0.51. The angle is already 82 degrees. That's fine. We're going to leave it at 82 degrees. And what is the through hole? Why do you think it's 0.27? You want to take a quick guess why it's 0.27? Well, the screw is 0.25. Can you take something that's 0.25 and put it into a hole that's 0.25? Not unless you got a big hammer. It's not going to fit well, is it? You have to allow for clearance. Okay, and that's what we're doing. You have to allow for clearance, select OK. Isn't that cool? You made your first, up here in the top right-hand corner, you can click on these different view. This is your view cube, right? Click on the front. Remember how this works? You can click on these arrows. Look here. You click on these arrows to rotate about the what axis, the Y. You can also rotate about the X axis. Look here. Okay. You can also go counterclockwise. All right. You can also go clockwise. And if you want to do isometric, you can click on the corners. So here, look here. Questions? Congratulations. If you're with me, we've created 2 holes. We've only got 3 more to make and add a chamfer and start doing the drawing. All right. Start 2D sketch. Start 2D sketch. Select this face here. And it's going to always reposition itself so that, again, your eyes are looking perpendicular, or your line of sight is perpendicular to that plane. We have to draw a circle. Circle center point. Move to the origin. It's going to turn green. Click. Drag out your diameter. Again, what is the diameter? Trying to get y'all to read these drawings. What's the diameter? 1.875. All right, enter. Do a right click. Okay. Now we have to add a special hole here. If you look at it, it's at the 9 o'clock position and it's a counterbore hole. Does anybody remember the reason for a counterbore hole? I quickly talked about the other day. What is the purpose of a counterbore hole? If you don't remember, you're trying to recess the head of the bolt so it's not sticking above the surface. In other words, it's below the surface. That's what we're doing. All right. Mr. Morris, how do you create that? Select point, and move your cursor near the 9 o'clock position right here and click. Okay. Thank you. We just located our point at the 9 o'clock position. Do a right click. Okay. It's there. I promise you the center point is there. Finish the sketch. Select hole. Is everybody with me? I hope so, but if not, you can go back and watch the video again, or I can come help you after the lecture. We want it to be a through hole. We want the center part to be a through hole, not threaded. We do want a seat. You have to be careful. Look how close these look a lot alike, don't they? This is the counterbore hole. That's the spot face. With the spot face, you don't want the head of the bolt to be recessed. You only want it to seat properly. Okay, if it's a rough casting, a rough surface, or a rough machine surface, you want to have the head of the screw seat properly. But right now, we want to hide the head of the bolt altogether. We don't want the head of the bolt sticking up. We want it to be below the surface. All right. We're going to go all the way through. What is the major diameter? What do you think, based on the drawing, what do you think the major diameter is? Are you sure? I say major, that's the largest diameter. 0.44 is the hole at the top. Okay. So we're going to make it, we're going to hit the backspace here and type in 0.44. That is this diameter right here. Now, Stephen, what is the through hole diameter? 0.27, right? Again, we have to have clearance for the screw. You can't take a 1/4 inch diameter screw and try to put it into a 1/4 inch diameter hole. That's not going to work, okay? Unless it's a threaded hole, and that's different. All right, so we have 0.27. What is the depth? What is the depth? See the little arrow that points down right by the number? Look at the dimension. Look at the dimension. There's a lot of symbols being used, May. May, you see that symbol? See the depth symbol? What do you think the depth is? You look at the little arrow. And in the note itself, the little arrow points down. What's the number beside the little arrow pointing down? 0.25. So we're already there. If you're not, you just type in what? 0.25, and it's going to give you the depth. Select OK. Yay. Guess what? We've got 3 of our 5 holes done. Again, if you want to look at it, you see that Dean style, but we have a hole here that's going to recess the head of the bolt. That's what's going to happen. Okay. We don't, why would you want to recess the head of the bolt? Talk a little louder, Potter.
So it doesn't stick out.
So it could be a trip. You might have something sliding. You might have one surface sliding over top of another one, right? So you don't want the head of the bolt sticking up, because you can't do that if the head of the bolt is also a trip hazard. If it's on the floor, right? A lot of times, if it's something related to the floor or the walls, you definitely want to counter bore the screws. All right, so we got to make another hole. So go to Start 2D Sketch, and click on this face. And as Mr. Morris likes to do this in the isometric view, but it's okay. Go to circle center point, click at the center of the circle. It turns green. Again, it's 1.87. It would be nice if we could do all of them at the same time, but guess what? We can't, because we have 4 different holes. That's why. Otherwise, if they were the same, we'd be done already. Do a right click, okay. Select point, come down at 6 o'clock. See how it kind of snaps? The little yellow dot. Click. Do a right click, select OK. All right. We've got, look, I'm hovering. There's my center point. I'm going to select finish. Now, if you don't like this particular isometric view, I can maneuver this by using the view cube. I'm going to go to hole. Now, this hole is a spot face. It looks a lot like a counter bore again, but you're not wanting to go, you're not trying to recess the head of the bolt. You're just trying to seat, S-E-A-T, seat the head of the bolt. Okay. All right. So we're going to select, we want this simple hole, and then we want to select spot face. And we want to go all the way through. And now we have to change our diameters here. What is this diameter? It's going to be the larger of the two. It's 0.44, right? So 0.44. And what about our depth? It doesn't give us a depth. You know why? Because we can make it whatever we want to, because we're not trying to hide the head of the bolt. Let's just make it like I think a 1/16 of an inch. That's a 1/16 of an inch, by the way. If you want to put in a fraction, you can. Look, you can put in a fraction. That's also fine. If you want the decimal equivalent, it's 0.0625. And we also want this through hole here to be 0.27 again. And select. Potter, are you raising your hand or stretching? Okay. Select OK. All right. Now we're getting close. Getting close here. We need to put a center hole, and that's the easiest one. Start 2D sketch. Start 2D sketch. Click on this face. Go to point. Select point. Move your cursor. You see it's going to turn green. Click. Do a right click with your mouse. Okay. Now, I told you this the other day. If I say click, if I use the word click, that's the left mouse key. If I say right click, that doesn't mean left click. That means the right mouse button. Okay. So click means left mouse button. The reason I don't say left click is because we do left click quite a bit. Right. So I just say click. But if I say right click, that means the right mouse button. And we don't do those as often. So that's why I emphasize right. All right, so I'm gonna select finish here. I'm gonna go to hole. And it's a through hole. It's just a through hole. Can somebody tell me what the diameter of this, no seat, what's the diameter of the through hole? Just 0.25. So come here and change it to 0.25. Now this is not, a screw is not going to go through this hole. Maybe it's a pin or something. Select OK. Now, a little bit later on, perhaps after today, you'll be researching what processes are used to make these holes. How do you set up a machine to make these holes? You and your teammates will be doing that, okay? And then we'll be doing it in the shop a little bit later. Okay, what do you think about these edges right here? If we cut this part on the horizontal bandsaw first, how many of y'all remember using the horizontal bandsaw? Everybody's hand should go up. You've used one, right? Horizontal bandsaw. What happens after we saw the part? What do we usually do next? Speak louder. You have to, did you say file? Why are we filing the part? Because we have rough burrs and edges, right? Well, you can also eliminate burrs and rough, slithers of metal. The reason why is we always want to practice good safety processes, right? We want to make sure that a person who is going to handle this part is not going to get a metal slither, and they hurt a lot. I know. Okay, so go to chamfer. We're going to put a beveled edge on this edge and this one, and we would do this on the lathe. Okay, so select chamfer, and can you tell by the note on the drawing what is the size of my chamfer? Look in the right side view and tell me what the size of the chamfer is. Look on your drawing. I'm sorry, I have to talk louder. It's 0.03 times a 45-degree angle. Okay, it's 0.03 at a 45-degree angle. All right, so 0.03. Watch. I've already typed in the distance. Click here. Click here. I just got rid of the burrs and the little slithers of metal, the rough parts that we don't want to get into our fingers or hands or something, when we're working. Say apply, and then close it out. All right. Beautiful. If your part looks like that, you've done a good job, but we really want to make this look pretty now. This is a generic material. But before we do that, let's go to File, Save As, and we're going to type in all uppercase letters. You only use uppercase letters on a technical drawing. Flange, space, bolt hole circle. By the way, that's what BHC stands for, bolt hole circle. And this time I'm actually going to spell it right. I'm going to put a different type of dash this time, multi-hole. See, I have like a minus sign now instead of a underscore. So flange, bolt hole, multi-hole. That's my file name. Save. Down here in the lower left-hand corner, you see the IPT. What does IPT stand for again? Inventor part. Look down the lower left-hand corner, you see a tab, right? All right. Now let's change the material. This is the browser. Come over to the browser. Hover over the file name. Right here is the file name you just created. Do a right click. Go to iProperties right here. And you're going to go to the physical tab. And see, the material is generic. Now, arrow down, and let's find alloy steel. So it's going to say steel, comma, alloy. Click on that, apply. Select close. Now, that looks like a real piece of metal, doesn't it? Isn't that beautiful? No comment? Isn't that pretty? Okay. Mr. Morris gets excited about machine parts. Okay. I'm a file, save. Now we have to make our drawing. Go to file. Raise your hand if you're with me. Wow. Some of y'all, most of y'all got your hands up. Some of you don't. That's okay. The nice thing about the video is you can go back and watch it again, and then you can ask me questions afterwards. Let's make this drawing. Let's take this home, okay, and finish this up as far as this part goes. File, select new. Now, you can't mix apples and oranges. It's got to be English, but we're not going to select standard IPT. We're going to select IDW. What does ANSI stand for? Remember what ANSI stands for? American National Standards Institute. So we have a standard that we follow when we lay out our drawings. Click on this, create. Look down here, you have two tabs now. Here's the part, here's the drawing. We don't have a plotter in this lab that will print this. That's a large sheet of paper, size D. We want a size A. What you have to do is come over to where it says sheet one on the browser, right click, go to edit sheet. And we want a size A. Select size A. And we can leave it, let's let it be portrait, like our drawing I gave you. Select OK. Notice it changed now to a size A. See, it says size A here. We can print that out on this printer. Go to base. Go to base. And we're going to leave it at full scale. That's what we left it last time, or when I did it before. I always do these ahead of time. I do it twice. I want it nice, so I do it twice. All right. So select OK. Now, if you want to move this, you move your cursor near the part. You see the ghost image of a square that appears, a rectangle. See that rectangle? Hold down the left mouse button, and you can move anywhere on the page you want to. I'm going to just kind of place it right there and just click anywhere on the screen. Now this is the beautiful thing. If you were doing this drawing by hand, you would not be able to do this, what we're getting ready to do. This is where the magic appears. Go to projected, click. I'm going to add a top view this time just to be different. Click here. Oops, sorry. Let me try that again. I did too quickly. Go to projected. See the box appear? When you see the box appear, click. Drag your part up. Click. Come down. Go to the right. Click. Come back towards the front view and go up at the 1 o'clock position. Click. Right click. Create. I'm going to do it again. So in case you blinked. Okay. But I'm not going to include the top view. The reason why I'm not going to include the top view, there's a lot of hidden lines that makes the drawing confusing. So I'm not going to include, we don't need the top view. The front view and the right side view is enough. So you can go ahead and hit the undo as well. Till you're back here. Once you're back here, go to projected. I'm going to click here. I'm going to come over to the right, click, come back, move up to the 1 o'clock position, do a left click, right click, create. All right. We got to rock and roll here now. Look, this looks boring. In the real world, you could leave it like this. In my class, I like for you to do something different here with the isometric view. Move your cursor near that view. You will see a red rectangle appear. When you do, do a right click. And right here, it says edit the view. See where it says edit view? Click on edit view. And right here where it says style, we want to shade that part. Shade it, click on this icon right here and select OK. And it made a liar out of me. So I'm gonna try this again. Do a right click, edit view, and I'm gonna shade the, now I think it's gonna take. There we go. One more time. One more time for good measure here. Move your cursor near the part, do a right click, edit the view, click on this icon, and you'll see the frame appear. Select OK. All right, y'all are doing beautiful. We'll be done here in about 10 minutes, maybe 15. All right, we have to start dimensioning our part. This is all beautiful. A lot of people can do this part, but this is where it separates the cream of the crop from just ordinary CAD people, okay? You have to dimension it properly. And I even left out a dimension. I've been doing this since 1980. So, and I left out a dimension. Shame on Mr. Morris. I left it out. I'm going to add it. We got to go to annotate first. Go to annotate. What does the word annotate mean? What? Take notes, add notes, right? We're going to add notes and dimensions here. Go to the middle of the screen and you will see a center mark right here. See this little center mark? It's like a little cross. Click on that. Click on that little cross right there. And look, you can zoom in if you want to. You can pan. How do you pan? Hold the scroll wheel down, move your mouse. Look, click, 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 click. Do a right click, OK. When you do a right click, OK, that gets you out of that mode. All right, now, that's all pretty and everything, but that's not, we still have to show, the whole circle. Look, right, you see this one right here? That's the cross we just used. Now, this is called the centered pattern. Click on this. And down here in the lower left-hand corner, it says, select the center of the pattern. Just select, watch, just select the outer edge of this circle. Then you start clicking, look. You start clicking these little circles here. Do a right click, create. I'm going to do it again in case you missed it. Look. You're going to go right here, click on this. Click on the edge of the circle, and then click on the edges of these circles. I don't have to click the center points because the edge tells me where the center is at. The edge of the circle tells me where the center point is at. Do a right click, create. Isn't that beautiful? All right. Right click. You can also hit the escape button. Does your drawing, raise your hand if your drawing looks like this so far? Did I leave some of you? Okay. Well, we're trying to go a little bit faster, but we'll have time to fix it. We got to add some dimensions here. Look, this is the easy part, but it's also the most important part. Go to the dimension tool right here, top left-hand corner, dimension. Look. Now, there's one dimension I didn't put on here. And shame on me because the most important one. I'm getting old. All right, click on the outer edge of the circle. And look there. The most important dimension of the whole drawing, and Mr. Morse, who's been doing this stuff before your parents were born, left out the most important dimension. Right click, OK. So it can happen to any of us. All right, now, this is the beauty. This is really nice. What I'm getting ready to show you next. Go to right here. There's a note called hole and thread right here. Hole and thread. Click on that, and you can go around and you can follow your drawing. Look, isn't that beautiful? A 1/4 UNC 2B hole. That's nice. Look, click on this one. Look, it's telling you what that hole is all about. spot face, the large diameter is 0.44, the through hole is, so. You can also, if you, now, let's say you want to move your view, right? It starts to get congested over here. All you have to do is do a right click OK, like I just did, and you can move your view, and guess what? It takes all the notes with it. Isn't that a wonderful thing? All right. Actually, I just now noticed I was being hard on myself, but I see that dimension is there. All right, the center hole. Look, dimension, click on the edge of the center hole. Click dimension, click on the edge, and I'm gonna drag that. You notice how I don't leave any dimensions on the part. It's really not a good idea. It doesn't look good. Your future employer is not going to be impressed with you leaving dimensions on the part itself. You have to manage your real estate here. You have to manage your real estate. So you have young eyes. Mr. Morris has left off the angle dimension, right? Angular dimension. Click on dimension. Look, click here and here. And look, I'm going to drag this out right here. Okay. Right click OK. Mr. Morris, that does not look good. That does not look professional. How can I fix that? Look, all you got to do is hover over this note right here, hold down the left mouse button, and guess what? Just drag it up here. Right click, escape. You can hit the escape. Now, if you hover, look, if you hover over any dimension, hold down your left mouse, you can drag it. Now, take your pencil, bless you. Take your pencil and check off all the, we're like 5 minutes from being done. Check your pencil and make sure Mr. Morris has added all the dimensions. Because let me tell you, Mr. Morris is getting 5 hours of sleep at night. So I might think I have all of them there, but I don't. Yes, Potter. Yeah, I know the right side view I haven't done yet, but I'm talking about that view. But you're right, I haven't done the right side view.
The interior circle.
Oh, yeah.
This one, very good. See, I knew you would find something. Go to dimension, and I'm going to click on that and drag it down like that. Now, you see how that's 2 decimal places? Let's say we want to make it 3. What you have to do is go to precision and tolerance. And look, arrow down, select 3. And arrow down here and select 3 decimal places. Okie dokie. All right, there you go. How's that? Now, let's go work on our right side view some. Do a right click, okay. Look, I want to move this over some. Now, I want to put some center lines in. These are called bisector center lines. Look up here on the menu bar. See this, Potter, right here? See this? Center line bisector. I call it the bisector. Click on this, and it's going. And now look, click on this and this. It's going to put a center line there. By the way, a center line is not actually a part of the part. It just indicates the center of the hole. One here and also one here. Okay. I'm going to do a right click, cancel. That's good. All right. Now we're going to look this hole and thread note. I don't need that now. I need this chamfer note. Look, chamfer, click on chamfer. That's the beveled edge. Zoom in, click on this edge and this edge, and look, there's that beautiful note. Look here, see that? Now, see how I'm saying, well, that's looking like congested, like the Hampton Roads Bridge tunnel right there, right? I'm going to do a left click, right click, okay. I'm going to move this note over here. Now it's not so congested anymore. You can move these things around. But you notice I have a note called typical. That's the abbreviation for typical. Double click on this note, and right below it, in parentheses, put in TYP. Close parenthesis, select OK. That means that's typical of all the chamfers now on this drawing, if you see that typical note that says basically all the chamfers are 0.03 at a 45-degree angle. All right. Now, what else we got to do? We got to add the, what's the thickness of this part? What is the thickness of the part? Can you tell me from the drawing? 0.375. All right, let's add that. Go to dimension, look here, zoom in, click here, here, and click. But guess what we got to do? You got to come over here and change the number of decimal places. Primary unit and the primary tolerance. Select okay. By the way, Professor or Dean Stabel, the more decimal places you have, the more costly it is to make that part. So if you see 3 decimal places, it's going to plus or minus the thousandth of an inch, which is 1/5 the thickness of a sheet of paper, because a sheet of paper is about 5 thousandths thick, and it's very costly. So you have to keep that in mind when you're designing something, the number of decimal places. All right. Something I require you to do, but industry does not require you to do this. Go to text and go below each view. We're going to go below the front view. Click, and we're going to, just like Word now, it's like Word. You're going to type in front view. You're going to hold down the left mouse button, highlight it, make it bold, underline. Okay. Just like you're working with Word. Right click, okay. Now, Mr. Morris cheats a little bit here. You didn't come to hear me say that, right? I'm going to right click on this view label, right? And I'm going to copy and look, right click, paste. Now, one of my students one time forgot to, I'm going to have to fix that. It's getting kind of congested there. Right click, cancel. He left that. Of course, I had to take points off of that because he's got front view. That's not. This is the right side view. Double click on that and you can edit this. Select OK. Right click on this one and we're going to edit this one to ISO. You've done these before. Select OK. Right click, escape. Now, it's getting kind of tight quarters here. So I'm gonna move my cursor near this view. Watch this. This is a beautiful thing. Hold down your left mouse button and you can move this down a little bit. See how it made some clearance there? Then you can come down here and move this down a little bit. Okay. Now I've got some room where I can reposition them. Normally you want that label to be somewhat centered, okay? All right, the very last thing, we're doing good. Let's save this first. File, save. And there you go. That's the file name. And look, we're a drawing number. Look, it put that file. That's the file name. That's also the drawing number. Now we have to fill out our title block. Because in the real world, your drawing has to go through a hierarchy process. When Mr. Morris orders things from work, it has to go to my dean. He has to sign off on it, right? Your boss has to sign off on this drawing. And I guarantee you're not the only one going to see this drawing. They have to initial it. And once it's initialed, it's approved. It goes to the next step. Okay? There's an approval process. And it's in the title block. All right. So go to the browser, right-click on the file name, go down to iProperties. Take a sip of my water here for a second. Go to Summary. Title. Title is flange, all uppercase letters. If I see lowercase letters, I'll take off points, but you can fix it. I'll redline it, you can fix it. But just get out of the habit of making lowercase letters. Bolt hole circle and then multi-dash hole. That is the title, the subject, CAD 140. Okay. The author is you. Put your last name, all uppercase. The manager would be me in this case. You're not going to make this until I approve it. And then the company, spell it out, Virginia Peninsula Community College. And the line there, anything below that line is just extra notes that you might, want to know more about this. You could say, classwork on 9. You don't have to type this. I'm just saying you could. Is classwork one word? It's close enough. All right, go to project. All right, designer, go where it says designer. That is you. You are the designer. Uppercase letters, last name. Unless there's 2 people with the same last name in here, then you might want to add initial or something. Engineer, you are the engineer. Authority is Mr. Morse, because you will not make it until I approve it on a 3D printer or on a machine. Go to status, checked by you. I want you to check your work to make sure it's satisfactory. Click on the date, or you can change the date. Engineer approved by you. We have a small staff here. You are the designer and the engineer. And then for manufacturer approved, you're going to put my last name and you're going to check the date. Okay, select apply, close. And there's your professional looking engineering drawing. We're going to say file, save. Now, how do you submit this, Mr. Morris? Look down here, you got 2. I do not want the IPT file. I do not want the IDW. I want you to save those for yourself. You will be making an e-portfolio. They have to make an e-portfolio at Dean Stabile and MAC 198. So they have to keep all their projects and the files, because they make an electronic portfolio that they can send to any employer. All right, so here's how you do this. Please pay attention. I'm going to go back to my, look, lower left-hand corner, click, there's the part. There is the drawing. Now, we're not going to be able to do that today, but you're going to make a modification to this part, not today. I'm going to have you put an alignment pin on it. An alignment pin. Well, here's what we're going to do. How do you submit this to me? First, one more time, I want you to save IPT file and IDW file to a flash drive or email them to yourself. Y'all tired of me yelling today, right? It's like a drill sergeant. All right, now go to file, export. I've got the drawing pulled up. Look, I've got the drawing pulled up right now. Just select PDF. And it's going to create a PDF of that file. Then y'all can send your file to Dean Stabile. He can open it up. He doesn't have CAD on his computer, but he can look at your, oh, Stephen, you did wonderful, right? Select save. There's your PDF of your, one more time, file, export, PDF. There you go. Save. Now, when you go for your interview, your boss is also going to want to, or your potential boss is also probably going to want to see your 3D model. This is a beautiful thing because you could put this in Word, PowerPoint, Excel. If you want to include your CAD data in there, you can. Google Slides, Google Docs. What's the other one? Google, what's the one that's like Excel? It's on the tip of my tongue. Sheets, Google Sheets. Okay. All right. So I'm going to file, export, look, not PDF this time, image. And a quality image is PNG. All right. Save. There are your submittals. It is now 9:29. Any questions? Yes. Can you talk a little bit loud? Yeah, I'll help you. Let me finish the video and I'll come help you with that. I will come around and help you with it. We got, 20 minutes left of class. So I will come and help you. I'm going to stop my share here. Hello, online students. I didn't forget about you. This is Mr. Morse. If you have any issues, please email me. Y'all have been doing really well. And just contact me if you have any questions, okay? All right, have a blessed day. I'm going to stop the recording here.